Good morning, I'm Clyde Buchan, and today I'll be presenting my dissertation proposal, where I look to spatially evaluate the multiple benefits of urban flood alleviation, with particular focus on a case study in Elgin, northeast Scotland. A coupling of more frequent high rainfall events alongside urban growth is increasing the need for provision of urban flood alleviation schemes. Whilst the primary focus of such schemes is flood mitigation, it must be acknowledged that spaces designated to this are predominantly under normal, non-flood conditions. Thus, there's a need to provide sustainable infrastructure with multiple benefits. Increasingly, focus is growing towards blue-green infrastructure in the flood management context. This may be defined as multifunctional green spaces which enhance ecosystem services, such as the ones below, and provide a range of environmental, economic, and social benefits, in addition to managing water quantity and quality. This is especially pertinent as urban growth threatens to reduce our green spaces and the ecosystem services that go along with this. However, there remains a lack of emphasis to move towards these practices from policymakers, in part due to limited quantification of these multiple benefits. Richard Fenner, an academic in this area, advocates that evaluating multiple benefits reinforces a positive feedback loop, as seen on the right, which acts to improve our infrastructure and optimize these benefits. Understanding of current practices will benefit future practice. A particular gap exists in comparing the benefits of blue-green infrastructure, traditional grey infrastructure, such as channel diversion, and hybrid approaches, which combine the two. It is my intention to identify these differences. To do this, I'll be using Elgin Flood Alleviation Scheme as a case study. The River Lossy runs through Elgin from west to east and has a history of bursting its banks, causing significant disruption in the area. Flooding in 2002 caused the evacuation of over 200 homes and millions of pounds worth of damage. This prompted the construction of Elgin Flood Alleviation Scheme, which ran from 2011 to 2016. There are several reasons why I selected this scheme. Firstly, it's the most expensive flood alleviation scheme in Scotland at £86 million and the largest civil engineering project in the Moray constituency. However, evaluations have been limited to cost-benefit evaluation, and a comprehensive evaluation of multiple benefits is yet to be undertaken. Most importantly, for my purposes, the scheme contains a range of different infrastructure types available for comparison. Here we have Boroughbriggs, an area of green infrastructure, which makes use of floodplains and flood embankments to avoid flooding. Here to the west, we have what we term grey infrastructure, more traditional features such as bridge widening and channel diversions and flood walls. And here we have hybrid infrastructure with the use of flood walls alongside green infrastructure such as floodplain and flood embankments. My aims then, firstly, is to identify multiple benefits provided by Elgin Flood Alleviation Scheme in the locality, and then look to relate this more widely to identify the respective benefits of blue-green infrastructure, grey infrastructure, and hybrid flood alleviation practices. Overarching questions within this would be what are the implications of results for sustainability of this scheme and approaches to flood alleviation in future schemes? How can we optimise these benefits? And can current methodology be used to further develop and identify multiple benefits of hybrid flood management practices, something not yet done? I'll look at 6 benefits related to flood alleviation practices. Flood protection, inevitably the most important benefit. Social benefits will be identified by property value change, an indicator of attractiveness and the value people place in the area. And green space accessibility, crucial for its links to mental and physical health. Environmental benefits assessed will be changes in habitat connectivity, carbon sequestration, and air pollution. Each of these benefits is measured on different scales, and thus I'll use an approach which normalizes these across a quantitative 0 to 10 scale. This is provided by this benefit curve, where characteristic values on the x-axis are converted into a benefit score. I will identify a before benefit and an after benefit, and then calculate the benefit uplift here using GIS. Here, I've made an example which considers green space accessibility. This is by no means a finished article, just something I wanted to include to show you how this works. Using Ordnance Survey data, I've measured distance from green space and the points where this space is accessible using a Euclidean distance, and then reclassified these values from 0 to 10 for both the before case in 2010 and the after case in 2017, by which point works were completed. I can then identify the benefit uplift across the scheme by subtracting the before benefit from the after benefit. This provides this raster on the right, where we can clearly see already some areas of benefit for green space. A similar process will be done for each factor. For my second aim, I need to identify the benefits within different areas of blue-green infrastructure, grey infrastructure, and hybrid infrastructure. Here, I have selected the area of Borough-Briggs, the blue-green infrastructure previously mentioned in the maps. The mean benefit uplift for this area is 1.1. That's the average of each raster cell in that area. The benefit uplift for each factor can then be displayed on a benefit profile, as shown here. And then the profiles of areas of blue-green infrastructure, grey infrastructure, and hybrid infrastructure can be compared. And this is an example given for another paper of blue-green infrastructure. In terms of expected results, concerning the first aim, I expect there to be a wide range of benefits in the local area. On the right here, we have a photo of that Borough-Briggs area. This is my brother and my dad enjoying the views across the floodplains with the river in the background. You can also see a cycle path here, which lots of runners and cyclists use daily. I assume that blue-green infrastructure and its association with ecosystem services will provide greater environmental benefits and social benefits, while grey infrastructure may provide greater flood protection. Benefits of hybrid infrastructure will probably depend on the combination of blue-green infrastructure and grey infrastructure used. This is probably going to be a particular area of interest, which could be developed further into new aims, looking to optimise the benefits of the study. In terms of next steps, these will focus around addressing potential challenges. Data collection has begun. I plan to use Ordnance Survey master map and open access data, including integrated transport networks, which is all accessible through EDINA. I'll also need to find property value data. I can then look to develop my GIS skills and look at potential tools which may benefit my study. For example, blue-green cities provide a toolbox in ArcGIS capable of evaluating some of my benefits relatively quickly. However, this would reduce my flexibility. I have over-input parameters to the models, and I thus might just use this as a basis for evaluating each benefit. I also need to begin dialogue with organisations close to the scheme. Particularly, I believe that the Moray Council and SEPA, who have an office in Elgin, could provide information and data which may streamline and further develop my study. Another area I need to read further into is to identify how to set clear boundaries for the influence of individual works. In reality, the scheme as a whole functions in unison, and thus dividing it into distinct areas requires some thought. This may be done by distinct physical features such as rows, or looking at boundaries that the council have placed themselves. Here is a brief timetable of what I plan to do. The next few months will be focusing on data collection, data cleaning and processing, and producing my model outputs alongside full-time work and exams. Into next academic year, I'll focus more on the writing part and focusing on dissertation conference and key deadlines. Thank you for listening, and I look forward to answering any questions that you may have.